going to have a look today at the equation of a circle and then some of the nasty things that go with it. So let's step right up and have a look at the equation of a circle. So let's just draw ourselves a little circle and let's think about this circle. What do we know about circles? Well, typically if we draw these on perhaps some sort of grid, then if that point is the center, and it's nearly on this one but not quite, then what we can do is we can work out various things about this circle. We'll know that this distance here is the radius, but in fact this distance here to the radius is the distance anywhere from the center. So we've got an interesting thing about working out where this center of this circle is and this radius. So let's draw this out a little larger, and if I just take this circle and I measure along a distance and up a distance, what we've got here is a little right-angled triangle. The formula for a circle is that x squared plus y squared equals r squared. Thinking about that, that looks a lot like Pythagoras, and indeed we're looking at here a right-angled triangle, and so it is. So let's see what we know. Well, this distance here might be x, and this distance here is y. And if I square this side and I square that side, then that gives me the radius squared. So I can work out about a circle. Given its radius, I can work out various other things. Given these distances, we can work out the radius, and so we can look at quite a lot of interesting things about a circle. So let's give ourselves an example here, and so let's take an example of x squared plus y squared equals 25. Well, easy enough to work out if that is r squared, therefore the radius here is going to equal 5 because it's the square root of 25. So we can give us the points here, and if we take perhaps a circle, the sort of equations we might get might involve trying to find out where this line of whatever equation this is going to be, and we're going to try and work out where that meets with this circle. So let's suppose this is a line, so this is going to be the line y equals x. Let's say here it's going to be minus 2. I'm just making a line up, and we've already decided that our circle could be the formula there, x squared plus y squared equals 25. And what I've got to try and do is work out where the two meet. Well, how are we going to do that? Well, we've got are two equations. I've got x related to y, and I've got here x squared plus y squared equals 25. I know what y is. It's that value. So I could put that value into y squared. This gives me x squared plus x minus 2 all squared equals 25. And so that's going to enable us to work out the coordinates at these 2 points. And because we've got 2 points, we're going to probably end up with a quadratic. And it certainly looks like that's what we're going to see here. So let's have a go at trying to solve this equation. I've got here x minus 2 all squared. So I need to work out what that's going to be. And I'm going to perform the claw. So x times x gives me x squared. X times minus 2 is minus 2x. X times minus 2 is minus 2x. And minus 2 times minus 2 is going to give me plus 4. Let's just sort this out. So that's going to give me x squared minus 4x plus 4. That goes back into this equation. So I've got x squared plus x squared minus 4x plus 4 equals 25. Now let's collect all the like terms. So I've got 2x squared minus 4x. I'm going to bring the 25 over to this side. It becomes minus 25, and minus 25 plus 4 gives me minus 21 equals 0. So what we need to do now is to simply see if we could work out the answer to this. And we've got several ways of doing this, but one way of solving this could be to use the calculator. And if I go to my calculator and I call up my menu, navigate through my menu, and here I've got my equations and functions. I'm going to solve a polynomial, a quadratic. It's going to be two numbers because it's an x squared. Here we are, here's my x squared, so I can put in my 2x squared. Then I've got my minus 4x, minus 4, and then I've got my minus 21. And this gives me my answer, which is not particularly nice, but if we do an SD of that, I've got here 4.39. So I can write down my solutions as 4.39 or minus 2.39. So this has given me the positions of my x coordinates. My x either over here at 4.39 or my position here at minus 2.39. Now I know that, I can substitute this into this formula to get the other positions. And let's do that. So I've got y equals here 4.39 minus 2, which is going to give me a value for y of here 2.39. And the other one that we can do, we can work out y equals minus 2.39 minus 2, which is going to give me a y value of minus 4.39 when x is minus 2.39. So I've got my coordinates, and they're not particularly nice ones, of where this line meets the circle. Now I've got those sort of values, then it might be that we could then need to work out perhaps the length of that line or something else. So let's see if we could try solving another one of these, just to sort of give you an idea about what we might be having. So let's draw out another one of these. So I've got my circle, and I'm told that this circle might be x squared plus y squared equals 169. I can work out that this circle will be having a centre of 0. So this will be 0, 0. And I can work out, in fact, from this that the radius is going to be the square root of 169, which happens to be 13. Now this line is going to intercept another line, and we'll have the line here y equals x. This time we'll do a plus 1, and we'll do plus 7. Let's see how that one works. What we want to do is, in this question, is to find out the points of intersection where these two meet. Where the two meet, these two equations equal one another, so I'm going to substitute this into there. So I've got x squared plus x plus 7 all squared equals 169. Now I've got that. My next stage I can do is to square this out. X plus 7 all squared. That's going to give me x squared plus 7x plus another 7x plus 49. Collect my like terms. X squared plus 14x plus 49. I'm now able to put that back into this equation. X squared plus x squared plus 14x plus 49 equals 169. Let's now collect the like terms. 2x squared plus 14x. I'm going to bring this 169 over, minus 169, so this is going to be, when I've done the subtraction, minus 120. And that will equal 0. To solve this, I need to just work out what this is going to be, and it's easiest to use the calculator. So let's go ahead and do that. So if I want to do this calculator, then simply my first value is going to be 2. My second value is going to be 14. And my last value is going to be minus 120. And that gives me an answer for x equaling 5 or minus 12. So I've now got my values of x. Let's substitute those back into this equation, y equals x plus 7. So first of all, we're going to make it y equals 5 plus 7. I'm getting ahead of myself, so therefore y equals 12 when x equals 5. So that is one set of the solution. The other solution is y equals minus 12 plus 7, and that's going to give me y equaling here minus 5 when x equals minus 12. We often notice these answers are very symmetrical, and the reason these answers are symmetrical is, of course, we've got a circle, and the circle is symmetrical as well. So what other ones might we get? Well, imagine that we've got a question where we're told we've got a circle. The circle has got a centre of 0, 0. And I'm told this circle has a radius equaling 5. Can we write down the equation of this circle? Yep, we simply can, because it's going to be x squared plus y squared equals r squared, which is going to be 25. What happened if they gave us the diameter? And they told us the diameter was 14. Then simply we work out what our radius is, and then we can write our equation down. X squared plus y squared equals the radius squared. So we can work out what we've got. Now let's imagine that we're asked to work out various other things. So let's imagine we've got our original question, and someone said that we've got this line, might need to know what the radius is, intersects with this one, but they could add some other things to say, well, if this is point P and this is point Q, could you work out the length of that line? Well, let's do that. I want to work out the length of a line. I've got my coordinates that I've worked out. Y equals 12 and x equals 5. I haven't written them as nice coordinates. Y equals minus 5 and x equals minus 12. Well, if we've got this, it's easy enough to work out what we've got. Now, basically, to work out the length of a line, what I've got is I've got two coordinates, here and here. This one is going to be minus 12, minus 5, and this one is going to be, didn't write it properly, 5, 12. To work out this line, all we've got to do is use a little bit of Pythagoras. I need to work out the distance here from minus 12 to plus 5. So it's going to be 12 plus 5, that's going to give me 17. And I'm going to go down here from minus 5 up to 12, and that's also going to give me a value of 17. So this Pythagoras is going to be 17 squared plus 17 squared is going to give me my length of PQ squared. I'm not that good on my 17 times table, so I'm just going to go in my menu to the main calculator, and I can work out what 17 squared is, and that gives me 289. So this is going to be 289 plus 289. Let's work that out. 578, and to work out my answer I need to square root the answer, and that's going to give me the lovely answer of 17 root 2, or in real numbers 24.04, which is going to equate approximately here to 24. So this line is going to be 24. What other things could they ask you? Well, typically if they're asking you to work out the length of the line, then sometimes they're going to ask you to work out things like the midpoint. So if I want to work out the midpoint, how do we do that? Well, we've worked out that it's 17 along and 17 up. Halfway is going to be half of 17. So that's going to be half of 17, which is going to be 8.5 and 8.5. So I start off with this position minus 12, and I'm going to add to that 8.5, and I'm going to start with minus 5, and I'm going to add 8.5. So this is going to give me my x coordinate, which is going to be simply, oh, we can put this into the calculator, or we could do it in our head. We can do minus 12 plus 8.5, and that gives us something silly because I didn't cancel first. Oh well, minus 12 plus 8.5, and that gives us minus 3.5, which you could have worked out in your head probably quite happily. And the other one is going to be minus 5, this time plus 8.5, giving us another coordinate of, this time, 3.5. So my coordinates of my midpoint would be my x value minus 3.5 and my y value of 3.5. So I can work out quite simply things like the length of the line and the midpoint, just when we're given exciting things like the equations of two lines, and we can work out the points where they intersect, and then from that we can work out things like the length and the midpoint. So we get quite a few of these types of questions, and they're not really that difficult. We just have to basically go through and check all our facts. Now we meet another problem, which is all to do with these circles, and that is I may have a circle and it meets a tangent. Now I know that it will meet the radius of this line at 90 degrees. So that's something that we already know. So let's try and see if we could find out various things about these lines. Well, if I know my radius, I know perhaps these points, and typically this might be at the point 0, 0. If I knew where this line of this tangent meets this radius, which it meets at the circle, so if it meets at the circumference of this circle, then I can work out various things, because we know that if these two meet at 90 degrees, then they are simply perpendicular, and that means we know something about their gradients, and their gradients will be this negative reciprocal. Let's try and find out something. So let's take this question. We've got our equation of our circle, and let's suppose that's going to be x squared plus y squared equals 25, and we're told that this meets a line at the point perhaps 2, 1. Now my diagram isn't strictly accurate here, because if it were going to do that, then this circle would probably look more like this, because it's going to be in the positive position. But I don't know. I've just drawn a circle. It doesn't matter, because here it's giving us an idea about what it's doing, and what we want to do is we want to try and work out something about these two. So what do we know? Well, we know it's got this point and we've got that point. Well, can we work out anything about those? Yep, I can work out the gradient from these two. To work out the gradient, we don't need anything about circles or anything. I know I've got the point 0, 0, and we've got 2, 1. The gradient, we know, is always the rise over the run. Sometimes we see this written as y2 minus y1 over x2 minus x1. So it's the rise, which is going to be 1 over 2 in this case. So for my radius, I know that the gradient here is going to be a half. How about this one? Well, if it's going to be a half, then we can work out the gradient of the tangent is going to be the negative reciprocal. The reciprocal of a half is 2, so it's going to be minus 2. And that would fit with this line to suggest that this line is going this way, which is minus 2. Then what do we know about this? Well, we know I've got our line y equals mx plus c. That's what I'm perhaps asked to work out. Could I work out the equation of the tangent? And I've got it going through these points. So I could write y minus y1 equals mx minus x1. So I can say that y minus here 1 equals, we know our gradient is minus 2 x, and we've got our minus 2. Let's work this out. Minus 2 times x is minus 2x. Minus 2 times minus 2 is plus 4. So y minus 1 equals that. Let's take the minus 1 over. So we're going to get minus 2x plus 5. And there is my equation of my tangent. So we've got the equation of the tangent worked out quite easily, and so we can work out various other awkward little problems. So what other nasty things could they think of to give you to try and do here? Well, sometimes what they ask you to do is find the area of a triangle, and this isn't really as difficult as it's going to be, because what they've got is always, when we're trying to work out these problems, we end up with right angle triangles, and if you've got a right angle triangle, we can work out quite a lot about it. So let's have a tangent beating a circle, and we need some sort of equation of this, and let's suppose we go that x squared plus y squared equals something like, I don't know, 20. And we might want to work out for this perhaps something like find the equation of the tangent. And let's assume it's going to meet at some point. We'll give it a label. There we are, there's A, and this is going to be 4 minus 2. Where do we start? Well, I know from this equation that it's simply at 0, 0. So we can work out the gradient of our radius. We're simply going to work out the rise over the run, and we've got these numbers basically take away 0, so it's going to be the rise, which is going to be minus 2 over 4, which is going to give me minus a half. The gradient of my tangent therefore is going to equal the negative reciprocal, which is going to give me 2. Okay, so I can now work out the equations of tangent, because we've got here a formula y equals mx, that's going to be 2x plus c. I know my values of x, which are 4 and minus 2. I can work this one out the other way just for fun. This is going to be minus 2 equals 2, and we know our value of x is 4. So I've got minus 2 equals 8 plus c, so therefore c is going to be minus 2 minus another 8, which is minus 10. So that's going to give me an equation of my tangent of y equals 2x minus 10. Now, other things they can ask you. Well, it says there's a point B here, and we've got to show that that point B lies on the tangent. So let's suppose we say that point B is going to be 2 minus 6. So will that fit on this line? So how are we going to work out whether these coordinates are suitable? Well, if I put one in, then we should be able to work out what the other one is. So let's put in the value of x. So y equals 2 times 2 minus 10. 2 2's are 4. 4 minus 10 is minus 6. So it fits. It is on the line. Now, can we find the area of a triangle like this, assuming that is point B there? We know this is 90 degrees, so all I need to know is the length of B to A, and I also need to find the length of O to A. Well, let's see what we know. To work out O to A, I've got the equation of my line, which is x squared plus y squared equals 20. I can work out from this that my radius is going to be the square root of 20. And my square root of 20 is simply here 2 root 5 or 4.47. I'm not going to worry about this too much at the moment because we're going to use this number to calculate here. So I know that distance is the square root of 20. Let's work out now from B to A. To work out from B to A, I know the point B is 2 and minus 6, and I know my position of A is 4 minus 2. So we want to work out my values here, and what we're going to need to do is work out a little triangle. I've got my value of B, which is here at 2 minus 6, and I've got my value of A here, which is 4 minus 2. This will be a right angled triangle, and I can work out what that length is simply by working out what this is. So this is my X value, which starts at 2 and goes to 4. So that's going to be a value of 2, and this one is my B value, which starts at minus 6 and goes to minus 2, which gives me a value of 4. So if I want to work out what BA squared is going to be, it's going to be 2 squared plus 4 squared. 4 plus 16 equals 20. So I've got here 20. Looking back up at this triangle then, I know that value is 20, and I know that that value is also, when squared, is 20, because I haven't square rooted either, because that could be the square root of 20 as that one is. So I can work out the area of my triangle, which was OAB. It's got 2 sides, and if I draw those 2 sides in, it's a nice easy little triangle. That has a side of the square root of 20, that has a side of the square root of 20. So the square root of 20 squared is going to give me 20 plus 20, which is going to give me 40. So we can work these things out to work out the length of that, but I want to work out the area, and my area is going to be the square root of 20 times the square root of 20, all divided by 2. I'll do that on the calculator. So I've got my square root of 20 times my square root of, ooh, don't like the way I did that, times the square root of 20. Now both of those divided by 2. And it wasn't difficult, and it gave me the area of 10 centimetres squared. So here we've had a little look at circles, the equations of those, and with tangents, and you can see that trying to solve some problems, not that difficult really, as long as you keep your head. So with that thought, thank you for watching GCSE Maths Topic by Topic. If you liked it, subscribe, and I'll see you again next week when we'll do some more maths. Until then, stay safe. Bye bye.